So our first speaker today is Zhiqi Tao from Intel. Dr. Zhiqi Tao, Solution Architect in the High Performance Data Division of Intel. In this role, Dr. Tao provides technical consultations to partners and customers. He evangelizes the Lustre technology worldwide. Right on. He has architected a number of high-performance computing storage solutions based on Lustre on a variety of hardware platforms. Dr. Tao received his PhD in computer science, information systems from the University of Melbourne in 2010, and his BE in telecommunications engineering and information science from, Jiaotong University in 2000. I hope I didn't butcher that. Zhiqi, was responsible in part, I think, for a really cool white paper on constructing Lustre systems, so that's pretty cool. Thanks for doing that for the community. Please allow me to present to you Dr. Zhiqi Tao.
Okay. Okay.
You good?
Yeah, this is actually exactly the same model I have. So when I hold it, I feel comfortable.
Well, that's nice. If you need a more powerful... Actually, let me go ask Justin.
This is good. Thank you. In fact, I have exactly the same feeling as Steve was saying. Like when people talk about big data, and essentially, what's the big data? If you look at all the issues they try to resolve, you feel like isn't that the same thing we try to, we have been working on in the HPC world for many years, right? Essentially, you have lots of data you want to process it efficiently, right? So you have a new framework, you have with different ways to organize data, more efficiently. But essentially, we have lots of data we want to process efficiently. So if you look at the entire system stack, you need to have lots of computation resource. You need to have ways to spread the job as widely as possible, as efficiently as possible, and ultimately, where data stay? Storage, right? Regardless of how powerful your CPU is, how fast your network is, essentially, data need to be loaded, right, to the compute node and to be able to process. And after the job is done, we need to save the data on reliable mediums, right? And this is like a load, processing, and store. This is the entire cycle, right? So if you look at this, like computation is in the middle, and of course, like a lot of people focus on how do I process data more efficiently. But essentially, if you do not have the efficient ways to read or write the data, this is a fundamental issue, and the total processing time is still pretty long, right? So with Lustre, we solve the first part, the third part, right? And with this Hadoop framework, we make this data processing and storage run closer, right? So altogether, we try to optimize the entire pipeline. So this is the agenda. I'm going to start with a general overview and talk about why we are doing this. And the second part will be the key topic, like how do I make it work, right? The third one, I'll present some benchmark results I did in the test environment I have access to, and talk about the future work, right? I want to start with here, right? So many of you probably know what here, like last year, you probably heard about Omkar talk about his work, right? And as you can see, right, this is pretty common thing, like when you have a talent engineer and make the technology can work and take another year for a solution engineer to understand how it works, right? So what do we want to do right here, right? So Hadoop essentially is the effective way to process data, right? And people might say, okay, Hadoop has what we have here, right? We have a HDFS, we have a map reduce. When people talk about HBase, Hive, all these things. So essentially, if we look at what Hadoop is about it's a framework to process data efficiently, right? And so the general concept of map reduce is like, so if I can employ more people to allow more process to do the work, I can get the job done quicker, right? And especially for unstructured data. For the structured data, like so the data, like you have to process this one in order to get second one work. For that, maybe not much, right? But with unstructured data, for example, let's say I want to calculate the word count, right, in a book, right? So I can have one person read the entire book, 2,000 pages, or I can have a 10 person, right, each on the one chapter, right? So because of there's no really dependency between different chapters, if I just want to calculate how often this word gets used, so in this case, if I can have more people to help me, I can get the job done quicker, right? And so this is the map, right? Reduce is, so if you get the results, let's consolidate the result together. That's reduce, right? So that's essentially, that's about it, right? In order to do this, that means we need to have a parallel file system in order to make the data available to all these worker nodes, like Hadoop worker node, right? And that's where the HDFS came in, right? So the Hadoop file system, right? But if you look at the Hadoop model, like conventionally, Hadoop model use like this 2U or 4U server has some internal storage, right? One of the important assumption is moving data is more expensive than moving computation, right? It's like, I'll come back to the book example. And if I have 10 friends help me, and one friend comes, oh, Zhiqi, you give me a wrong chapter? Fine, like process this chapter and forget about the old job. Right? That basically means moving computation, right? You get the worker nodes to process different data, right? So this is why if I don't have to move data, I get the good result, right? And this is why Hadoop has an assumption. That's might be true for the small scale, right? But for scale like HPC environment, you might find several deep challenges. First of all, we have a very dense computing cluster, and the compute nodes, like for example, we use the blade system a lot, right? There's practically no storage space. So how do I make that Hadoop work there? And also, we have this like a job running, like different job running on the same cluster all the time. And if I cannot afford just to make this node to be dedicated Hadoop node, right? There may be other MPI jobs running. I want to easily repurpose the machine. If all the data stored locally, it's much harder, right? So that's where all this work started. Like, so if I can consolidate the data into the single, like high performance file system like Lustre, and that works best, right? And so that will suit the environment. I can get things, get Hadoop jobs running in the HPC environment. But also, if you look at another thing is, the data with Hadoop HDFS is not really the file system you can use right away, right? So you still have the same issue. You load the data into HDFS, and then have the job run, and then you sort of like download it. With Lustre, it's just a directory once you mount it, right? Like, so the data processed, and you can use it right away. So that's more efficient. And also, you could have the freedom to scale out the computation and storage separately, right? If you include, I need more computation resource, you probably just add more computation node. And the Lustre side, if you have enough bandwidth, you don't have to expand your storage. But you find, I have lots of data I need to process, and you can add things more on Lustre side. And another factor is recently I've been working with one partners, right? So they are seeing the issue like, they have the data and the computation co-located on the same node, this kind of architecture. But after a while, they realize the computation take pretty much all of the CPU cycle. The storage become incredibly slow, right? It just gradually becomes slower and slower. So that's kind of thing drives them crazy and say, well, and I'm telling them, okay, right? If you look at you coming from big data, you coming from the big data background, but essentially, if you look at GPC, like we know that's kind of Amber, yeah, yeah. So this is essentially the same issue we saw before. We know that like you separate computation with the storage, right? You have a dedicated computation jobs just handle the computation. You have a dedicated resource to handle storage, right? So they are moving towards this, like they heard, oh, you guys can do this work, and that's great. Like so, they're moving towards this, architecture. So in this chart, I have a. Oh, this is hardly noticeable. So in this chart, I have a Hadoop on top of Lustre. It does not mean like you will run Hadoop job on OSS or MDS. You still run Hadoop as a Lustre client, right? And so it's just data stored on Lustre. So how do you make it work? Basically, we create this. We use the Hadoop local file system class, and we create a new scheme called Lustre. And so that's way Hadoop node will know they talk to Lustre, right? So in fact, because the way HDFS works, it can basically work with any file system, right? So without this class, you can still get it work. But so what's the like a innovation part of this adapter, right? So if we just use that, let's say another example, use an FS mount to the client, right? What you got is like the node would be able to save data on the like a parallel file system, but they wouldn't know they are talking to the same file system. You will still have the same shuffle phase. Shuffle phase means I try to map the computation job to the data to be processed on that node. So basically, you have a high-performance file system. They all talk to the same central file system. There's no locality anymore, but the Hadoop node wouldn't know that, right? So what we have done is we improve that process. So you do not really talk to your local data, you talk to the data stored on Lustre, and so you don't have the movage, right? So this is the optimization on the shuffle phase is the key contribution of this adapter, right? This is why we optimize entire I/O path, even though on the traditional like small I/O, which is not ideal really for Lustre, but still you find the Lustre perform better in this case because we optimize the I/O path. The whole operation becomes simpler. All right, so how do you make it work, right? So basically there are 4 steps. First, install step, set up Lustre, mount Lustre, and install set up Hadoop, and direct Hadoop I/O to the Lustre file system, right? Instead of using so I just talk about the way I know. Of course, like we have many intelligent people in this room. I'm sure like you probably find a different approach, and by all means, and feel free to do so, right? So first of all, we need to do some preparation. If you have already been running Lustre in your data center, most likely you have already have a centralized the naming server, like either LDAP, NIS, or Active Directory, right? So you have that, great. Let's just add a couple of Hadoop user, like Hive, HBase, HDFS, Map Reduce, Yarn, this user into your system. If you don't, you have a small system like the one I use, and you can use this short script to do that, right? So essentially, what we want is we want a consistent UID, GID between node, right? And we do not want, because the way Lustre works is like we map the user ID, group ID into the permission. So you might find if you have different one, Lustre gets confused. So we need to have this consistent UID, GID. And second, we need to set up an environment like this. For example, with a proper Lustre setup would have a shared storage, right? And would have a 2 MDS, in my case, I have a 4 OSS. I use SSD on MDT, and I use the 16 OSD I have a 16 Hadoop node in this environment. Other than a regular like installing operating system, install Lustre, there are actual things we want to prepare, especially the local NTP server, right? I'm not sure for environment, but the environment I work on they have no direct connection to internet, so I want to have a consistent clock between all the nodes, right? In the cluster environment, the one who makes noise might not be the one who actually causes problem. So in this case, we want to correlate event, correlate log, right? So without consistent log, I can hardly tell, if these two events are related, right? So that's why we want to have a local NTP server. Also, we want to have the local YAML repository. This is probably suited to the environment I work on, because I don't have a good connection to internet, and I just use the local one, and that's efficient ways, right? So if I don't need to pull the data from internet. So set up Lustre. I assume everyone in the room know how to do that, right? If you don't, feel free to approach me, and I'm happy to help. Right? Once you mount the Lustre file system from all of Hadoop nodes, I have a 16 Hadoop worker node, right? So I have this Hadoop. I have this Lustre file system mounted. It's 166 terabyte, right? So before I do anything, I will just do a quick DD process, make sure the file system is indeed okay, right? And then second step, install Hadoop, right? To install Hadoop, so there are a couple of things I want to say is, first of all, you want to make sure your YAML repository is functioning okay, right? Do a YAML clean all and do a YAML repo list, right? And see if your YAML repository works fine. And also, there are Hadoop distributions shipped with the Java runtime environment. In that case, you want to uninstall that one, because that's a conflict. You might have a hard time just to get the Java working, right? So that part is always something I try to avoid. So what I did, I just uninstall any pre-build the Java runtime environment. Then run the install script. Install script most likely is wizard-based, right? And you just answer a couple of questions. You get the first Hadoop node build up, right? For the test I was doing, and I use the distribution has the adapter built in, right? And so I didn't have to install the adapter separately. But really, install step is really simple. Just copy the jar file to the certain directory, right? So set up Hadoop, right? Personally, I like to take things step by step and always be skeptical, right? So what I do is first, to verify the Hadoop installation and to set up the Hadoop with HDFS, right? Even though we're here to set up Lustre, but let's make sure Hadoop installed correctly, right? So if you have this kind of management interface, you can verify if you can start HDFS and Yarn. Yarn is a map reduce job scheduler, right? If they can start these two processes correctly, right? Then afterwards, run a simple example, for example, this one calculated pi, right? And so if I get this job done correctly, I know my Hadoop installation correctly, right? So as a part of the process, you probably need to replicate Hadoop to all of 16 nodes, right? And so this is an important steps. When you do so, we will need to repeat the same replication step after we change the configuration. Right. This is one area we often get the errors. So finally, how do I direct I/O to Lustre? Right. So there are a couple of things. First of all, let's start with the SU doer file. Right. I don't feel I understand this SU doer file well enough yet, but what I notice is location of the configuration does matters. right? Doesn't matter, right? So what you want to do is you search for default, search for view, add this tuple, like Hadoop group do not require TTY, and Hadoop group can be SU door, right? So search for like default and search for view, add the line underneath, right? So another step is to make sure the Lustre adapter is loaded, right? And so what we want to do is we want to add exports is use Lustre equal to true to this template file. So this is when the template file, like the way they use a puppy, right? Like to replicate the configuration to all of Hadoop nodes. So you add it here, and we need to to replicate the configuration to all the file, all of a Lustre node again. And also we want to create a Hadoop data directory, like make mount Lustre /Hadoop, and change it, make sure that directory is usable by all of our Lustre clients. And then, because we already verified Hadoop installation, we stop all of Hadoop process, right? Then in this time, we select yarn and alternative file system, right? And that could be could be anything, right? Like so, it could be NFS, could be Lustre. So the point is, we do not use HDFS this time. As part of that setup, we would edit this attribute, right? So the first thing is the file system root directory. And we create that directory /mount/Lustre/Hadoop, right? And then create this temp directory, like Hadoop temp dir, and also make sure like they load the Hadoop Lustre the module. And also we need to edit this map reduce property, and these are the two fields, right? Like the shuffle and the collector. And there are different ways to do this. Like if you have the UI, you can do that, edit it from there. If you have the text version, and so you probably need to edit this XML file, right? But essentially, this is the property and the value you want to put down there. So the next step is a start yarn process, right? Because we don't use HDFS anymore, we just start yarn, right? That's a single process, be fine. And the common error at this stage, like you might see, like yarn cannot start. Number one issue will be like the consistent UID GID. So if you use a script I create, and I'm sure that work, right? And also the permission to write to Lustre file system, right? And so I did not do a fine-tuning job. Like I just use the very easy way to make it work. And also the third one is, when you edit the parameter on the Hadoop manager node, right? There's no guarantee when you edit it, the property will be replicated to all of Hadoop node, right? So you want to make sure, like for example, if you have the management tools, you will select the configuration nodes, provision service, right? That means like I roll out a new update, right? So after we make Hadoop talk to Lustre, now we can verify if Lustre is indeed the file system we use here. We use like Hadoop fs -df message. You can see now we have this Lustre file system, right? Previously, if you do not have this, if you have a HDFS, it will be file : // right? So this is indeed Lustre, and then I would do some fine exercise. So what I did is download the book, right? And I do the word count, right? And while I'm doing this, I have a look at the Lustre file system to see if there are I/O going on, right? So after I get this part done, I know like my installation is successful, and I can start to some benchmark, right? So IOR test is the baseline, right? Basically, I want to validate what's the performance I get from Lustre system, right? I got about 4,000 megabytes per second, and I also did this, DFS IO and from Highbench, right? The result like is about the same, right? And so in this environment, the bottleneck is on the storage side, right? So the next what I like to do is if you have access to bigger cluster and can be temporarily available for this kind of benchmark, like I would like to try it on bigger scale, like say more than 100 node, and especially I want to have a very fast Lustre file system attached to that. Say, for example, if a Lustre file system can do more than 50 gigabytes, right? And that's probably show the more efficient bandwidth. And also, if you have some real-life application, right? I'd like to hear from you because synthetic benchmark is important to get the baseline, but there's no guarantee you will get this good performance afterwards, right? Like, so we still need to do the real-life benchmark. And also, the strength of Lustre is performance and scalability. So I want to hear, like, you have a lot of data need to process, and you need to get it done quick, right? Sooner than later. So that means, like, that's what the performance can buy you, the time, right? Like, so that's what I want to hear from you. And also, if you have some application which has a lot of eye candies, like cool to show, and maybe we can collaborate and put up a show at the supercomputing later this year, right? So, thank you. That's all I have. And any questions?
The connector you're using, the file type, whatever it was, the macro was, it seems like that would work for any distributed file system. Is that correct?
No.
In other words, let me rephrase my question. Sorry. If the only changes to Hadoop were to be able to access the different sections of the map file globally, so that you can get to any section from anywhere, then and changing the reduce phase so that you don't have to remap those things does not work for any distributed file system. In other words, what's Lustre specific about this is, I guess, what I'm trying to say.
Yeah, because that's probably true. In fact, you have a very good point, right? And because once we mount, you can see the steps, like I mount the Lustre file system long before I install and have any Hadoop process running, right? Once we mount the Lustre file system, basically it's just a directory from all the Hadoop node, right? And essentially it's a shared file system, but from a client perspective, they don't know, right? There's no knowledge from a Hadoop layer. That's probably true, right? But I haven't tried it.
So you could use it with like NFS or something if you wanted to just try it easily.
I didn't try it, but that might be good things to try, and yeah.